Well, hello there, and welcome to the stream. Turn that down, move that over. Look at this. Look at this. It's a game, sort of. How's everyone doing? Welcome to the stream. Thanks for coming. Don't forget to like, subscribe, and do all that stuff that you're required to do by law. It's the truth, and it's the law of the whole world through the one world government. You must like and subscribe and share. And if you want to chat, you have to subscribe. I turned that on. I don't know if that's a thing. Hey, I've got coffee here, so I need to mute myself. Two reasons why I have to mute myself while drinking coffee. One, because I slurp, and there's a microphone right here by my mouth. Two is this. Listen to this. Listen to this. Hear that? That is the sound of a tiny cup being put down on a tiny coaster that vibrates through this microphone arm, and I think the springs inside the arm vibrate, and then the microphone picks that up. Yep. So I will now show you what I've been working on, because I actually have a plan here. You can see in the console, perhaps. I shall also make this a little narrower, because it is very wide, and it's wider than the stream can hold. There we go. Now you can see the console here has a lot of the stuff about angles and directions, and I don't know if it's correct. It seems like it might be correct, but let's check it out. So I'm going to make this... Oh, what's this? Interesting. So this is 2021.3. This is different than it was last time I clicked it. So there you go. Let's see if this works. I know, this is what happens when I've got a day off, Toad. Alright. Alright, so we are now in the game world. Magic. And check this out. So, we've got bows on some of these first two characters here. This one, both have bows, you can see. These two don't have bows. So, when I go over this, you can see now there's a targeting thing. Oh, and that little blip is my attempts at shooting arrows to try to get the angle right. But you can. So I think I'm gonna. So as you get closer, the blip gets smaller because you're closer. So that's gonna be like the angle or the range. Like it could be that you shoot the arrow and it goes right over the shoulder through that empty spot, but you're much more likely to hit when you're close. Oh man. Okay. And then when you're far away, can I turn that off? Well, I can't really turn it off. So what I'll do instead is go to the other direction, because I think right now those particles are kind of not working right, and they're going down this hill, not up this hill. So, all right. So what I want to show was, yes, as you're farther back, the area is bigger, and then it gets smaller the closer you get. Now there is an animation curve attached to this value, so technically there could be different bows with different curves. Some may be more accurate than others, which is really cool. Others may be less accurate, and then the accuracy will be modified by the player's accuracy value and perhaps other values, and also the enemy's speed value. And that is because it's an RPG that does not require finger dexterity. It requires your characters to have things like dexterity. So there you go. That's pretty cool, but now what the heck's going on with this other thing? Let's make this not maximized. So now, where's my character? There's my character. So you can see what's going on here, and you can see where the problem is at this point if I... There we go. So it's spitting out balls. Those spheres are meant to be going and hitting that target, and they're not. As you can see, they're clearly not hitting the target. So this is the issue here. Now, I spent a few hours last night getting this working. The targeting part worked pretty well, and there's also a Z offset right now. Also, by the way, I was watching a Jason Wyman stream yesterday on this tabletop RPG thing, and I saw that he was putting in temporary variables with all caps, and I thought to myself, that's a snazzy idea. I should do that too. So I've put my temporary variables here, min size, max size, speed, as all caps. Size curve should probably be all caps too, because I do think it would make sense that some weapons have a different curve than others. Maybe slightly different curve. I don't know. So that should be on the weapon. And then I was on the forums, and I found this thing about angle. And so I think if we look at just the console as I get closer and further, so you can see that the angle gets closer to 90 degrees, or really negative 90 degrees. So negative 90 degrees would mean flat, that you have to shoot, hello Magic Tim, that you would have to shoot the arrow straight, and it would go directly into that arrow. But of course we want to have some sort of trajectory, which means that from this distance you'd have to, put it 5 degrees above, 5 degrees above lateral or horizontal, or whatever the word would be. And as we go further back, that goes up. So currently at the very back, this would be 70 degrees. So 20 degrees up, whatever that is. 45 is like a diagonal, so halfway between 45. That way the arrow will go up a little bit and then fall down. So that number looks correct, or it looks like a number that I can work with, even though it's negative 70 and negative 85, The thing that I'm getting at, that I'm hoping somebody watching this stream right now can help me out with, and if we can get this working right, maybe we can even make this a free script for people to use. The thing is, all the trajectory, etc. stuff that I've found has been about previewing trajectories, similar to Angry Birds. Like you pull your finger back and it changes the trajectory. It gives you a prediction of where it's going to go, and it's accurate, but you're not giving the same inputs. In this case, I know the destination. Right now it's going to be the middle of that target. There's a transform on the goblin that has a position. I know the start position, which is going to be the camera position for now. I might modify that slightly to make it that if she shoots, it comes out from here. If this one shoots, it comes out from here. So maybe it'll come out from here or up here or something like that, or behind the camera, but here. So it's just slightly modified so you can see slightly different angles. That would be cool. So I might do that. But I know the start. I know the end. I know the velocity / speed. And I know gravity. What I don't know is the angle. Now, I think I know the angle. I think the angle is this. So I think I have everything I need in order to shoot it. Basically, I should shoot a projectile at this speed from this position at this angle, and it should hit this target. But it's clearly not working right now. So if we look at the code, this is where it gets, you can see I've been, let me zoom in, but not too much. All right, you can see I've been attempting to do different things here. I've got some commented out versions. These are all from the forums because that's what we do, right? So we're getting the angle. So shoot sphere is being called with this get angle. That's getting that negative 70 number, negative 80, negative 85 number. So I have that number to work with. And what I'm currently doing, I'm creating a new primitive sphere, putting it at the camera position. That's my start position. Just making it smaller, just because. We can actually make this a little bit smaller too, I think. doesn't have to be 0.2. And then we are disabling the collider so that they don't collide with each other or other things. And we're getting the rigid body. So I've saved the direction. Where do I save the direction? Where is direction saved? And I'm not sure if direction actually makes sense. So, by the way, in high school, I had been in all these honor classes for years and years, all the gifted smart kid classes. But at some point, I stopped liking school, so I started getting bad grades. I just didn't care anymore. And so, come to 10th grade, and I wasn't in honors math anymore. I had been kicked out of that. And I was no longer able to be in the normal math class with my grade. So I had to be in the normal math class with all the kids a year older than me, which, I didn't know too many of them, so it wasn't the best thing. And that 10th grade was all about geometry and trigonometry. I sailed through, got a good C probably, passing grade, and stopped taking math. I just focused on theater and creative writing and all the fun stuff, So I stopped taking math. And so geometry and trigonometry, to this day, I don't like it. I don't like it one bit. So when it comes to this stuff, not a fan. Anyways, so direction, this is, again, something from the forums. Oh, no, this isn't from it is from the forums. Ultimately, I did modify it. But so this is basically putting the target particle position. So I should specify that target particle position. So it's returns a position right in front of the target so that the particle doesn't cut through the bad guy. So that's where direction is coming from. I was debug logging it here so I could see it. Not sure if it helps. And so now my understanding is I have to do the add force, and I have to add the force at a specific direction. And I don't know how to convert this angle into a direction. Does that make sense? We can look up add force here in the web browser. Oh, it's in this window. Let me look it up. Let's see. Unity 3D add force. Rigid body add force. So according to this, we just need this vector 3 force, which I believe is like the direction multiplied by the speed or velocity. In some cases, I think they were doing speed times speed, which might make sense because this is never the correct. So we can try that just for laughs. Let's see. So again, we're going to look at the player character really. Okay, so now it's going out further, which is great. I don't think. I don't know. Let's eyeball this. Is that enough to hit the target? Oops. Where's the bad guy? No, that's clearly not going to hit the target, even if it was pointing at the target, right? It's not going to make it there, but okay, that's something we can work with that. What I'm really looking for is can I get the direction right? Right now it's going off to the right. I don't know why. So if we go back into writer here, I just don't know. So this one is actually this up here. One example on the forums said this. The other said this. And if I'm looking, seeing the sign here is for the wrong component, and the cosine is on the wrong component. Also, math pi versus degree to radians times the get angle. And maybe negative get angle. Let's just try negative get angle, just to see, because it is a negative angle, and I don't know where angle 0 is supposed to be. If that's up, if that's forward, down, left, right, etc. All right, so now we're going the opposite direction. All right, that's fair. So maybe what we need to do, if we know, negative 70 is the number. Negative 70 is positive 70. So if we need something in the middle, how about we do get angle? We'll do this. We'll do bar fixed angle equals, to get the middle, we'll do 90 plus get angle, which is really going to be 90 minus whatever the angle is. And we'll put fixed angle here and here, and we'll see what that does. Maybe that will do right in the middle. Maybe it will be through the back of the head. Chris Baker, hello, welcome to the stream. I used this as a basis for my projectile, but in this case, they're not using physics. Yes. Yeah, that was the other thing I was thinking. Like one of the suggestions actually on how to draw the curve, because I want the player to be able to kind of see the projectile curve, especially if they want to see that it's going to hit a dungeon ceiling or something like that. One of the suggestions was to basically shoot the projectile and get a list of all the positions along the curve, and then use that to move something along. So that might be the final method I use. All right, so look at that. Now it's going straight up. That's interesting. So I was hoping it was going to go forward, but instead it went up. So now I guess we know where we're doing the angle currently on whatever axis that is. So on this axis, which is, I don't know which axis that is. Not the Y, not the X. We're doing it on the Z axis. Oh, I have no freaking clue. Angles. We're doing it on the up down axis, apparently. And maybe we're not. Maybe we need to be taking into account the player and their position, because I mean, I think it would make sense that we would need to take on the player's position when we do our get angle. How does that work? So this is the code from the forum. It works. Sorry, I forgot to mute my drinking coffee. It totally works, but I don't know. I don't know what it does. It works, I just don't know what it does. Yeah, so how about we play with this? Make this 0 and put that in that axis. Yeah, my original arrow was just doing a transform forward or translate forward. Just basically it moved forward until it hit something. It went in a straight line, which cool. That's cool. It works, and for most things, I think that would be perfectly fine. But oh, look at that! Now we're going sort of backwards. But as you can see, we are always going backwards. So no matter where we are, it's going the same direction. And if we're on this side, it's still going the same direction. So it's clearly also not taking into account the player's angle. So we're going to have to do that. So I'm going to try one more thing here. Actually, I'm not going to do that because that's just going to muddy the waters a little bit. I need to add the player's angle. I'm going to make an assumption here that this is getting it from world space, whatever the default angle is. And I need to get the player's angle in relative to that. So let's see. Unity 3D, get player angle relative to world space. Would it be just, let's see. Game.player camera.transform.angle. What's angle 2? Would this be or maybe this could be the enemy object? Hover enemy.transform.position. Wait, what is this looking for? Okay, just that. So I'll need to move that up or this down. Okay. And debug.log player, player angle. Okay. Let's try that. Wait, what's this? Transform, inverse transform point? I'll have to try that out. Let me try this and then I'll look that up. All right, well, it's not changing, but I am getting an angle that appears to not be going around. So that's not, it doesn't appear correct. All right, let's see. Mithran suggested transform.inverse transform point. What does this do? Okay, the opposite of transform point, which is used to convert from local to world space. So I am kind of dealing with directions is what I'm really looking for. So really what I need is the transform direction. Or something. I don't even know if I need this actually. I don't. Okay. You know, I'm going to go back to basics. Let's see. Unity 3D, add force example. How about that? All right, good. What is this site? There's a whole bunch of answers. Okay, that's not. Ooh, this is an old one. Ha, Jason. Maybe you can actually help me because you know maths, I think. We're working on getting the code right to make my arrows fly properly. And I'll show the rundown to get you up to speed because math, trigonometry, and geometry, man, these are not my strong suits. So I've got this wonderful little arrow target thing here going on, and as you can see in the scene view, I've got these fake arrows going out of my head in the wrong direction at the wrong force, and they need to be going towards this arrow target, but they aren't. And so I've got in the console here, I do have an angle I can work with, which I think is accurate. As I get closer, the angle gets more horizontal. As I get further away, the angle gets more up in the air. It's a number I can work with. I'm not sure exactly. I might need to modify it to be 14 instead of negative 76 or whatnot. And I have a direction between me and the bad guy here, which is accurate as well because that's being used for that targeting particle. So those two are correct. The player angle isn't probably nothing. So I'm trying to figure out how to add force. And so now I'm suddenly thinking, okay, I think I need to multiply direction according to this very old post in JavaScript, it looks like, maybe. Vector 3 is going to be the direction multiplied by the speed. And then, so that's where I am right now. Hi, Merrick. How are you? Welcome to the stream. I'm glad you were able to make it a reasonable hour that isn't 4 a.m. for you. So I've got all these other things I was trying out, as you can see, with fancy things like pi and cosine and sine, all from the forums, mind you. So what I think now is I'll try doing this. If we take direction times speed times speed. I don't know why, but speed itself is never enough. So that's another thing. Even speed times speed isn't enough. So I don't know what that's all about either. So let me just try that. And we'll just go with that. This is just the direction. No fancy maths. That's already been taken care of. All right. Attempt number 55. All right. Goes backwards. So question is, does it go backwards all the time? Oh, it seems to be going backwards relative to... All right, so that's something. It's always going backwards, which means it's just reversed, right? I mean, whoops, wrong button. And this one. Well, that's exciting in a way, because what if I do negative direction? Is that a thing? It's probably not a thing. All right, negative direction. Oh. Well, maybe that's a thing. All right. Force types. I have been seeing the force types. Force mode. I kind of read up on this yesterday, but it was a little confusing. I was tired, though. So we have start, impulse, acceleration, force, velocity, change. Oh. Start does nothing. A continuous force using its mass, acceleration, impulse. I would think it would be impulse. It's an instant force impulse. My browser's suddenly super slow and not working. Force mode, impulse, just like that. All right, let's try that. Let's try that. I don't know what the default is. That's why I was actually thinking about that last night. I was thinking, I don't know what the default is. I'll just go with it. Shoot an arrow tutorial. Okay, well in this case, the balls are, where are the balls going? They're just going straight down. I can't even see where they're going. Let's change speed. See if that allows us to see where the balls are going. All right, so they are going forward. So okay. Let me stop doing the speed times speed thing. And see if that fixes it. Because maybe speed times speed was not the right way. Okay. All right, look at that, a little closer. Now, it's not hitting that target, though. You know why? It's not doing the angle, I bet. It looks like it's going straight forward. So, okay, we are so much closer now, though. Like a billion times closer now than we were before. I don't think it's mass. I think the issue here is that it's going straight. I have the direction between me, the player, and the bad guy, which is a straight line. But I also have this angle, knowing that I need to go on a curved line up. Yes, I could destroy those spheres too. Let's see. I will add the destroy. New or destroy. Is this new sphere? 1.5. We'll do 3F just because. All right, so we will destroy those in 3 seconds. So what I need to do now is modify direction by the angle. Does that make sense? And that's what I don't know how to do, because I'll draw it out in Adobe Photoshop. New file. Hey, look, I'm working on icons. It's a preview. All right, so what we've got here is a failure to communicate. Do you remember that song? Some of you remember that song. You know exactly what I'm talking about. All right, so we got our good guy here. Yay! I don't know why this is black and white, but oh, I chose red. Yeah. Okay. Apparently it's in grayscale. Whatever. We got our good guy. We have our bad guy, and we know it's a bad guy because it's got horns. Okay. And right now we have the direction, which is here, and that's where the arrow is going. So it's going down because of gravity. We also have our angle, which is here. And so what we really need to do is shoot the arrow up so it goes there and then blood splatters everywhere. So I need to modify direction. Whoops, that was loud. Direction by this angle. Do you like my drawing? I'm really good at games, drawing games, you know, Jackbox, etc. I'm not. So how do we do that? How do we modify a direction by an angle? Can I get a direction relative to the angle from the player and then add them together? That might work. So Unity 3D, get direction from angle. Vector 3 angle. I think it's going to be transform angle. Target direction. No, this is not right. Ah, see, you knew. That was your sly way of saying I know what you're talking about, but the rest are too young. Uh-huh. Uh-huh. Ha 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 ha. Frost Game Dev, add relative force. No, it's going to be this angle. I swear it's this angle, because when we saw that ball shooting out, it was shooting straight forward, and I think it just needs to be shot up at that angle in order to hit the target. I'm just not sure how to get an angle of just the direction, get that vector 3 direction from an angle relative to the player. So this is where we get into the trigonometry. Angle in Euler's. I want that the ball goes to the direction of the angle, but how to calculate? You need these. All right, so I'm gonna take a chance and just copy paste and not understand cosine and sine and we will take our angle and we will save our angle direction equals new vector 3, and we'll say direction x, direction y, and 0, and then we will add these together. I also always use parentheses because I never remember the order of math operations. See, I think my audience is old enough. Chris knows, and I think my audience is old enough. I have a feeling that the folks who come to all these streams, we're all older than we look and certainly older than we act. That's my guess. I haven't done a poll or anything, though. All right, let's see if that does anything different. Oh, okay. It did something different, but look, is that going off to a weird angle, a weird direction? I think it might be. Okay, so it's going whoo, out there, isn't it? All right, but it is angled now. What happens if we go over here? So it looks like it's not being modified directly. It's oh, now it's going. Oh, okay. Yeah, we can clearly see here that it's going at an angle on a different axis than we want. Right? Or I guess not. It kind of is going the right axis. It's just not modifying it relative to the player. Right? So it definitely gets higher or lower. I don't know. It's doing something, but it's just not right. It could be that these are wrong. It's okay, JT. You didn't disappoint me, actually. You know what I like watching on YouTube? If you're ever bored, look up old 80s shows from like Poison, Guns N' Roses, Motley Crue from Hollywood Boulevard. Is it the Viper Room or something like that? There's videos of their early shows there, and it just, I mean, I was a kid at that point, so there's no way I was dressed up as a punk rocker for Halloween at that point, but it's crazy times. I can't imagine what it was like to be in those shows and to be at that place in that time on the Sunset Strip. But pretty neat stuff. So if you ever get bored on YouTube, look that up. All right, so it's being modified, but I think it's being modified in the wrong way. I don't know which. the angle parameter computed? It is, I don't know. So what I do know is that it goes from negative 85, negative 90 would be straightforward, up to negative 70 when the arrow will need to be angled up. Yes, arrow trajectory. So I know the angle is, we got the angle here. So negative 90 would be flat. So really, I guess if I want to say, hey, add 0 to it, if I want direction to be 0, 0, 0, then angle would have to be, or angle direction would have to be 0. So I wonder if it was negative 90, if I just say plus 90 to each of these, I don't know if cosine of 0 and sine of 0 equals 0, but if that's the case, then if this were not 0, then this should be 0, 0, 0, and we'd be adding 0 to it, right? So let's see. All right, so we are indeed, well, not completely. No. It still feels like it's doing the wrong, is it the wrong axis? If I'm on the right of it, it goes that direction. If I'm on the left of it, it goes this direction. And as I get further closer, seems to be, whoa. Yeah, so we can see the angle at work there. It's going this weird arc around, and it's just going way further than it really needs to. Do I need to normalize the angle first? Yeah, so it's just basically taking the forward and going around like a circle. You can kind of see it. Imagine draw a circle around the bad guy. Well, the problem is really that this is the actual shooting of the arrow too. Like, this is how I'm going to shoot the arrow. All right, let's see. I feel like I need to make this angle direction relative to the player, because I think direction is in world space. Angle direction. Why is well, Parabola sampling functions. All right, this one could be promising. Huh, doesn't work. That's funny. This is a fair amount of code. So what are we doing here? We have a start, end, velocity, acceleration. Plot. Not sure what that means. We'll figure that out. Okay, so we get the direction. Get the horizontal direction. Vertical difference. Before I go down this hole, let me go back to this one. So all right, we'll try that real quick. A simpler link. Where did you send it? On the Discord? Somewhere else? Let me see. Let me bring this over here. Okay. Keep that there for safekeeping. Test the last change, see if that did anything at all. I'm sure it did something. Okay. Well, okay, this is perhaps better. I don't know actually. Still seems to be doing the same thing, doesn't it? It's going off in weird... this circle around it. Rather than... like it's just on the wrong axis, you know, or something like that. Let's see what this looks like. I don't like confirm my choices. Okay. Yes. So this is what I'm looking for. All right, I'm going to copy this and then we'll dig into it. So, hold on. So, let's see. This appears, object that moves, timer. That's different than what I was thinking of doing, but that's okay. Let's figure out. Transforms, that mark the start and end. Okay. See, I guess this height thing. This is yeah. If I'm reading this correctly, what it's really going to end up doing is this would be my arrow. That square thing would be my arrow, and I'd have to get the arc here and just move the arrow along the arc over time, which I guess is fine. It's not using physics. That's probably fine. All right, so let's make this copy and modify it. All right. I'm gonna throw this down here, and I'm gonna get rid of that. I'm gonna move these over. This is going to be, we'll call this tick, and then we'll call tick from our actual update. And that should solve that issue. All right, we've got these things. We'll have to assign some object. Or maybe it's signed down here. Okay, so we can remove A and B, we can do start's going to be game dot player camera dot transform. Actually, I think I player camera position. I made an easier one. Is target position, target particle position, or position arrow target position. I believe that's right. Yes. Okay. Yep. Height is H. I'm gonna get rid of those so I can see. Get rid of those. So we don't need any of that. Because we have those. We need an object still, so we'll need to solve for that. Or object T. Let's change this to object timer. More clear. And H should be height. Cancel. Whatever that was, cancel it. All right. Okay, so if not, then we'll return, and then we'll do just this. All right. And all right. I think we've changed all. The only thing we're missing now is the some object. And what's time? How is object timer? Time mod 1. So that's just okay. I see. So that we just need to have a random object. Okay, that's fine. So I've got this sphere here from a previous. Nope, that's not that. That's not it. I'll just create a sphere. Create sphere. Test object. We'll make this 0.1 and make those. What is this? Oh, relative. Interesting. Okay. That's neat. All right. So make that 0.1 and some object. If not that, or if null? No, not null. That's not right. Yeah, if we don't have that or actor target. Okay, this is doing. Okay, so if no game return and if no actor target, return. So if we don't have a game or an actor target, then we'll not do those, I guess. Will that solve this null reference? Okay, let's press play. See what happens. Oh, look at that. Oh, and it's also hitting it. So that's nice that it's hitting it. We can turn off the sphere collider. Okay, so look at that. It's working to that degree. We can see, what can we see? We can see a doesn't seem to be going at much of an angle, but that being said, if I just go straight back, this should still run even when I'm out of range. Yeah, so it's not going at an angle yet. Right? It's just going straight. There's no angle happening here. Okay, so progress. So let me do a couple things. Turn off this collider on the object. Let's look at the code. All right. Where does height come into play? This really needs to be named something different, but I'm going to do it manually. And find the red dots. That was it. Ah, here we are. How do we get height? So this is okay. I see. I didn't. Good call out, Merrick. Because I didn't set height. What I was looking for was that the height would, be adjusted for, the distance, and I think in this. So this is height is just hard coded. See, that's not. Gosh. Okay. Maybe I can modify it because I don't want height. I mean, let's just do 5 for now, and see it, and we can talk about it. And also, let me stop because I want to stop those balls from spitting out. It's just distracting. So maybe we might be able to math this out, but let me stop the balls from spitting out first. So say return on that. All right, so let's visualize this. Now I'm expecting there to be an angle, but I'm expecting that angle to not match physics. We can also fake it too. It doesn't have to be actual physics, really. But let's start by visualizing it. Oh, it didn't actually do it. Why? Oh, okay. All right, there we go. So what we have here is a failure to do physics. So obviously it's going up to the height of 5 regardless of where I am. So it's gain an angle to that, but it's always going up at a height of 5. Now, I know when I get closer, I want it to be more horizontal. When I get further away, I want it to be more angled. I have an angle still that's based on physics, which is nice. So if I utilize that angle to modify the height, what I need to do is get the height at the, so if I you know, let's go Photoshop. New. Why is it, there we go. I don't know why. Anyways, so first we're gonna have our good guy. It's green. So this is our good guy. And then we have our bad guy. We know he's a bad guy because he's got the horns. All right. So in one place, like if the good guy's right here, then we want the angle to be kind of like this. But if it's back here, then we want the angle to be like that. So a higher angle. So we know we have and I'll make this pink. We have a angle. Say, well, that's too much of an angle. We're really like this. So we have this angle, and we want this thing. So what we need to do is find this height. So if I shoot, if I were to shoot a straight line at the angle from here to the midway point, does that make sense? I think I might just be making shit up right now, but if I shot a straight line here, and I know this straight line, I need to find this height. That's H. As the angle comes down, H will come down too. I think that's basically right. And of course, I could just fudge it too. You know. Let's try fudging it first. Fudging it, by the way, for non-Americans, I don't know if fudging translates in other English-speaking languages either. It means faking it. I don't know why. Fudge is good. Fudge isn't fake. Maybe fudge is just a short word for the word fuck. But that doesn't make any sense either. Yeah, I think, Corey, I think that's the route I'm going to go. Faking it in some way. And if that works, if that feels right, then I don't think the rest matters. It doesn't have to be actual physics. Like, maybe some nerd out there will be like, that doesn't look like actual physics to me. I know physics. But, you know, that nerd can write to me and then help me do it right. And I'll make an update. How about that? And I'll thank them for their service to the cause. All right, so we need to set height. Height is going to be so we're gonna have to do a couple things. We'll do public float min height equals 0.5 or 3. We'll just do that. And public float max height equals 3f. We'll just set those, and then where's distance? So height equals math.lerp between min height and max height by distance. No. Wait. I think I did this math already somewhere. Yes. Size multiplier. So I take the distance minus the melee distance, which right now is 3. And I have the max distances here. So for now, I'm just going to copy this because this is, I believe, the right thing to do. Let's try that. Fudging has nothing to do with the food. What? Captain Fudge? Oh. Well, that sounds like an old wives' tale that might actually be true. This is the thing I like about the English language is I never know where some words originate from. You know, they could be from any old English-speaking place, or they could be borrowed words from non-English-speaking places. It's very exciting. All right. Well, that seems to do kind of the trick, except, man, that height should be like, minimum height should be really, really low here. Let's see, 0.1. And yeah. So if I'm lower than this guy, all right. And then if I go further back, are we seeing the angle go up? Let's make the max height something crazy high. That's weird. Doesn't, oh, yeah, so it only updates when my target is on. That makes sense because that function is in the targeting. So it does seem to go higher, so let me just get the right number. Something that feels right, and we'll move from there. 3 feels too high, right? Plus that looks like more than 3, but maybe it's not. Okay, let's make it 1. See, this I kind of feel like there's going to have to be some more maths to figure out here, because I like the idea that some bows, being stronger than others, don't have to angle up as much or something like that. Which is why I was trying to base it on just the physics system. And then like a crossbow with a lot of force can just be horizontal for the most part. You know, and this matters because in dungeons, small corridors, caves, you won't be able to shoot as far if you have to shoot it angled higher, because it might hit the ceiling by the time it gets there. Okay, but that appears to look right. Does that look right to you? And it would come the other direction too. When the bad guys are shooting arrows at the player, this would also be utilized. Huh. I've never heard the term hoisted by your own petard. I like when the conservatives in this country say that people need to pick themselves up by the bootstraps, because clearly that's impossible. And yet they use it seriously to say that people need to work harder to help themselves by giving something that's an example that's entirely impossible. All right. So, how are we going to make this work for an arrow? We need a list now of these positions along that line. So what is this doing? I have to say, I actually prefer the physics method still, because if I could just say add force and it just at the right direction, the right force, and it just gets to where it should be, that seems a lot easier than this. You know what I mean? Because I can see how I can use this, right? I'll put this into a static method essentially, and it will return result. What's result? There's a vector 3, so there's just a position. So it's going to return the position that the thing should be at. It will look at its the direction of its last position to its current one, which is going to, could be close enough for the arrow pointing forward on that arc. I can adjust time by distance and speed. So, if it's one meter and it goes 1 meter per second, then it would be just 1. Or start at 0 and go to 1 over 1 second. If it's 10 meters, then it will start at 0, go to 1 over 10 seconds, just to do the, divide by distance. So I can see all that. It just seems like that's a lot more computation on my part than just using the physics engine. It also doesn't take into account what if two arrows collide against each other. The idea that an arrow could fall down is interesting. But maybe it doesn't need to be that detailed. We're not doing large scale battle simulations here. It's just a silly RPG that just has a little bit more realism than shooting an arrow straight forward. So I guess that's probably fine. So I guess what we need to do is put this into a static class. make this a static method. Is that right? You're going to see some of my naivete here in regards to making this a static method or static class. So we're going to do public. What are we going to do? Yeah. Where are we going to put it? There we go. Okay. So we're going to do public static class, and we're going to call this arrow math. See if this works. So it needs to be static. So static vector 3 sample parabola parabola. And then when we call this here, what we can do is say arrow math dot sample. Oh, we gotta make it public. Public static, okay. And then if I remove it from here, I'll get an error. The other places that's being used. So arrow math dot sample parabola. So that should work. Hey, look at that, I did it. Good job, me. I get a gold star. Let's see if it worked. I'm just checking to make sure it does the math as expected still. It does, okay. So I'm going to fix these to 1.1 and 1. Okay. Parabola midpoint. Is that for the height, Mithrin? To look up parabola midpoint for the height? Okay, so now that we have this in an arrow maths class, let's move this to its own file. How do we move this to its own file? All right, so we have arrow maths, math. It didn't open it. Okay, there it is. No. Okay, that was enough. All right, float t time. Well, this is going to be an issue. Is this going to be an issue if they aren't level? Because what if I want to shoot up at a someone on a cliff, or shoot down from a cliff? Let's find out. Okay, so let's turn this on. Now it's on. Now we'll select our first person camera. I do not like that they changed the world space thing to be a drop down. That's so annoying. Yeah, so God damn it, no. I think it needs to be physics. I think there's just too much that I'd have to do to modify, because there's going to be a point at which it should not work, you know? Like, if I'm way down here, there's no way that the arrow will actually hit that because of gravity. Sounds like there's people doing gardening outside, so I apologize if you hear machines. Ay, Dios mío. I think this is annoying. This is annoying. That's what I think. All right. I do like this. I like the gizmos. I feel like there's probably something I can pull from this. But I also feel like I need to do physics. I need to do physics. It's gotta be physics. All right, so let me go back to the very basics of this rigid body thing. We're going to put this up here. So we are going to start by just saying game.player_camera.transform.position times speed. No, this has to be a direction. Transform forward. There we go. So start with, we're going to go down to just, can we get it going forward from the player's position? Screw the rest. That might help me understand what the heck's going on with physics. That was a fun aside, and I think I might make use of that later. But for this purpose. All right, so it is going forward. It is going forward. Okay, so we have it now currently going forward. Now, we know it's not supposed to go forward. It's supposed to go in the direction. So, if I instead make it go in the direction, just do a quick little thing. What's the difference between player forward and direction? Oh, by the way, I should share the link that Jason, I should have done this earlier. I apologize. I should share this in the chat. This is the link that, nope, that's not it. Remove that. Where's the link? That was a, yes, look that up. Okay, so this is the link that Jason had shared with me. There we go. So if you're curious about that, or if you want to save it to your Obsidian file for later in safekeeping, you can do so. All right, so let's see what happens now. All right, so we discovered earlier that it was actually negative direction is the way to go. So let me do negative direction, and that should go towards the bad guy. One step at a time. I think part of my MO is to try, like, for these things that for me are more complicated, just try to get a solution, copy paste, see if it works, and then see if I can kind of modify things to make it work. And then if I can't, go back and do the very basic thing, one step at a time, trying to get closer. All right, so we are at the correct direction now. So what we're going to do is add a new variable up here, and we're going to call this public vector3 temp angle. All right, and in our shoot sphere, we're going to add temp angle to direction, just so we can understand what the three things do. And I think this is going to be where we have the issue between world space and local space, but that's okay. I just want to understand a little bit more, if I can, about the three angles and all that stuff. Which angles I think we talked about in the game dev show a couple weeks ago, about quaternions and etc. Okay, so hit control so the mouse doesn't move that, and we have, oh, wrong thing, actions. So I'm going to add just 0.5 to this, to x. See what happens now. All right, so now it's over there. If I go negative 0.5, is it going to be to the right? Yes. All right, so 0.1 on the y. Okay, let's do 1 on the y. All right, so that's clearly too high, but 0.5. All right, so is this going to be correct? Oh, it is. It does seem to be doing it the same regardless of where I am. Okay, so now we need to make this modified by, so it's clearly the temp angle y. That's the only thing we need to figure out. So we have our number. Let's make our number a positive number. So negative 90 would equal 0. And we have, say, negative 80. So just so we'll say fixed angle equals that plus 90. So that should give us a positive number between why is this? It's fine below. Okay. Adjusted angle. So that'll give us a positive number between 0 and, I mean, in this case, it's never really going to go more than like 20. But if it's negative 70, then we'll be 20, and that's an angle up. That's the number we're going to add. And then we will normalize that by saying our normalized angle equals adjusted angle divided by 90. Okay, and then we will add, new vector 3, 0, 0. All right, let's see if that works. If it works, then that's great. If it doesn't work, then we'll figure it out. In the end, this should be a fun little mini mechanic in the game to work with. Okay. Is it adding an angle? It appears to be adding an angle, doesn't it? Let's just visualize this by coming down here. All right, it does appear to be adding an angle, right? It's very hard to tell because it's a subtle angle. But definitely doesn't seem to be flat, because that red line is flat. It's also not hitting the target. When we're really close, it hits the target. But the further back we are, it doesn't hit the target. So, the actual target, by the way, is on the goblin in the center of the chest. The yellow particle is just offset towards the player. If anything, I would need to increase the force of the projectile. Let's see. I have it at speed 15. Problem is I'm using speed to get the angle. And those should, I mean, technically line up. If I do 20. If we do 40. Yeah, so 40, it's much more flat. See, the angle is, since the force is so high, it doesn't need to be so, so it's super flat at a huge force. And if I go 5, like really low, speed's not the right word, it's actually. Yeah, so now the angle's much higher, but there seems to be a disconnect between the physics result of the angle math and the physics result of the shoot. And there's always a chance. When angle is 0 means, I think it just means it can't get there. Oh, that's different. Yeah, so technically when angle is 0, it can't reach the distance at this, like it needs to be this close in order to hit it. It's just slightly off, right? Because it's landing at the feet or the knees, and then when I get closer, it's landing higher. So there's a slight disconnect between the two. So I had it at 15 before, and I think that's a fine starting place. All right, so what is the difference? Is it this force mode? Continuous acceleration, probably that. Let's try that. heard an audio blip. I'm not sure why. Hi everyone. Thanks for watching. Please like and subscribe. Thanks. Thumbs up. Click the bell icon. All that stuff. All right. Well, that seems to have not worked. All right. So force mode dot force. I feel like this is going to make it go woo crazy. Let's see. Oh, no, it does nothing. Okay. Maybe because it only happens one frame and that needs to happen every frame, but I'm not doing that. Dot velocity change doesn't seem right. We'll try it. All right, well, it's going forward. It's essentially doing the same as impulse, it looks like. Right, where it's just not quite right. Okay. All right, so let's go back to impulse, which does seem right because impulse says add instant force using its mass, which is essentially what an arrow does, right? Instant force when it gets released. All right. So we have the angle, which is wonderful. We have the direction. We're doing that. The speed is different. So how are we computing our angle? Oh man, yes. This is from the forum. So I'm gonna change this a little bit. I'm gonna say return -1, and if get angle. And we're going to say if get angle is less than 0 or equals -1, then return. I might do more there, but stupid apple. Okay. I can do this stuff. Yes, that's essentially it. Yeah, so it's not going to be any range, because if the arrow can't reach, the force won't get there, then it won't. But the idea is that in the game, this little circle, once it comes up, I will explain it. All right. So in the game, you will have this little circle there, and the circle indicates where your arrows might hit. I mean, they're being hidden right now by all these spheres, but when you click the shoot button, it's going to choose a random position inside a sphere of that radius and shoot there. So that it might not actually hit the center of mass; it will hit somewhere. But I just need the arrow to land where I want it to land, essentially. So I'm trying to stretch. I'm just trying to get that math right, essentially. I know the numbers. I just don't know why the numbers aren't lining up. I think yeah. So this code from the forum is not quite doing the same thing as the others. So we're giving it velocity, speed, gravity, the distance, and this is the flat distance. And y is probably height, I suppose. I don't know what y is. Velocity squared, velocity to the power of 4. I don't know why that needs to be there. Where's v4 come into play? This looks like physics. Yep. So this I don't understand. I mean, I understand basics of it, I suppose, but I don't get the why we're doing square root of v velocity to the power of 4 minus gravity times x squared plus height, I suppose, times velocity squared times 2. I don't know where times 2 comes into play there. So JT, you're saying you would have just expected an arrow to have a maximum range. Player has to adjust height. Yeah, so that's where I want to not have the player do that. You know, in a game like Skyrim or many other games, that is part of the game, is that you learn how to aim the arrow to hit. But in this game, whether you hit or not is really determined by your stats. There's no physical dexterity involved in it. Like if you're better at mouse clicking, that doesn't give you an advantage over a player who has never clicked a mouse before. It's really just the stats and a random roll. And of course, your luck stat, as many things in this game, may give you a slight advantage, as it may give you the better of 2 rolls if your luck is itself rolled to come into play, and the higher your luck value is there. So it has nothing to do with where you aim. You're always aiming at if your mouse is over the bad guy, then that's what you're aiming at. Whether your character actually hits that or not is really just random. And that's where this angle seems to make sense. There's physics here. there, it's given me an angle that makes sense. It's just that the speed here has to be the same as the speed in the other one, and it's not giving you the exact same result. And the other one is the one that actually shoots the arrow, which will have a rigid body on it and all that. And maybe that's the difference. Arrow target particle, not arrow. That's my actual arrow. Where's the sphere I'm shooting out? Oh, it's just being created in the code. So maybe I need to not have the collider doesn't matter, right? Yeah, collider shouldn't change anything about it, really. If I change the size, does that change the mass? I suppose we need to know the density or something. Mm-hmm. No. So that's not changing really anything. It's doing the exact same thing. It's just a bigger ball. All right. And these giant balls. Mass of 1. So what if I set the mass to be something else? What if I set it to be 0? Has no mass. And I want to change the size back to, we'll do 0.5 because it could be even smaller, right? Right. Okay. Well, I have a feeling they're going really far away. All right, so maybe mass of 0 is a bad idea. All right, we'll make it mass of 0.5. See if that does anything. All right. Wow. So mass has an effect. Look at them go. Is mass not taken into account on the angle calculation then? Because this is just getting a velocity. And with mass, velocity will change, right? With physics, the velocity changes with And this is a constant velocity. That's why I need is a constant velocity. Whereas this does not give a constant velocity. But the other force modes weren't any better. I mean, this says it's ignoring its mass. So that sounds better then. If that's the case, that the angle calculation is ignoring mass, then this would ignore mass too. But I think before this had the same result as impulse. Yeah. Pretty much the same result as impulse. So what if... Yeah. I think that's the same result in this case as the ball. I'll put it back. But what if for our angle here... What if we just add 10% to it? Right? What if we maybe there's some error that I just don't know about here, and if we just modify the angle by 10%, 20%, you know. Looks like it's probably not going to work, but let's do this. We'll do angle mod. Oops. This way we can actually play with it, see if it does anything interesting. This just makes the angle higher from further away relative to what it's supposed to be. I've got the window open. It smells like there's a fire. All right. So look at that. It's kind of hitting him in the middle. Kind of hitting him in the middle. So that seems to work. Anyone have any random objections or thoughts on why there needs to be a modifier to the angle? If I go really far back, does it get super high? Well, we're not going to be able to shoot that far away necessarily. It does get higher, so maybe 1.5 is not the correct amount. Maybe it's supposed to be 1.4. 1.4 mean anything? It's a little too low now. So 1.45. I think if we imagine that arrow moving a little bit to the left, that center of it, the plus sign in the targeting particle should be where it hits, and it looks like it is doing it about there. So 1.46. Is 1.46 a magical number in physics? Appears to be hitting him in the same part of the stomach no matter how far back I go. Which tells me that this will work for this purpose. Oops. Why does it work for this purpose? I don't know. I mean, technically, this should work now, given these random numbers. What happens if I do change the speed? Let's see. It's solving for the fact that the angle I was getting was not quite right. It seemed to be too low. And so now we are increasing it proportionally by essentially distance. We're just multiplying it. If I change the speed to 10, then what happens? Do I still hit it? Not able to hit it from there. Yeah, so that's not going to work. So the mod is not universal. It works at 15 speed, but doesn't work at other speeds or other velocities necessarily. Or maybe it's just not at slower velocities. Because that appears to be working. So, all right. So if I just make the minimum speed 15, then this should technically just work for this purpose. It's not, though, a solution I'm happy with. I wanted a solution that I could just share on the Asset Store for free and just say, hey, give these and you get this out. But maybe it works fine then. So speed just needs to be a minimum of 15. It can be higher and it would still work. So if I have like a crossbow bolt that goes crazy fast, that would work. All right. Sometimes, if it works, just go with it. I know, they look like magic to me too. It's just, angles have always been an issue. From the very beginning of making the barbarian. Alright, so now how am I going to use this? So arrow system. All right, we need our arrow particle. Public game object arrow particle, or arrow, just arrow, not our arrow. So eventually I think we'll have different arrow types maybe. That's always fun, I think. Although maybe it's not. Having to manage arrows is kind of annoying in some ways. So maybe I won't, but we'll see. We'll go play by ear. So now we have an arrow. So now we're going to make it shoot the arrow. And maybe somebody's barbecuing. Maybe that's what it is, not a fire. Okay, so we're going to shoot the arrow. Zoom in here. Left mouse click. Check the left mouse click. If it hit an enemy, shoot clicked enemy. And that is going to do this, right? Yep. So what we're really going to do here is say arrow system dot shoot. And what do we need to pass into this? The arrow system needs to know. Well, it's got the hover enemy, so it knows that. We're going to have to pass more information eventually, but for now I just want to get an arrow shooting. So we already have the enemy. Maybe we don't need anything else. Let's see. Thanks, J Cheese. Thanks for hanging out. I'll see you another time, I'm sure. Thanks for participating in the chat, too. I appreciate it. Okay, to shoot, what we're going to do is essentially what we've been doing, but just once. Shoot sphere. So we're going to need to get the angle. And let's copy this. We're going to have to delete a bunch of it, but that's okay. Okay, so we're going to instead make new sphere is going to be instantiate arrow at camera position and quaternion identity, new arrow, and we'll destroy the new arrow after never. We can ignore this. We can ignore that, and that, and that. We'll keep that. We'll keep that. Okay. Excellent. I'm glad to go for a walk with you. I actually woke up late today. Today is a day off for me. I took a day off because if I don't, I run out of that, or I don't run out. They stop accruing, and so I have to force myself to take random days off, and today's one of them, which is why I'm doing a daytime stream. And I was going to go for a walk this morning, but I didn't. Today it looks cloudy outside. I've got I always have the shutters or whatever they are, the blinds down, because otherwise people walking outside would just see me in the back of my monitor with all my colorful lights, and I think they'd look and be like, "What the hell's that? That's weird." The kids these days and their TikToks. But it's not. I've got the window open a little bit. It doesn't feel warm. Well, it says it's 21 degrees Celsius. I've been trying to learn Celsius, so I've got my weather app, and I think that's about 70 something, 73 maybe. 70. All right. So it's about 70 degrees outside, but it looks cloudy. It says it's partly cloudy. It's going to be like this all day. And it's not going to get much warmer. Interesting. Next week is summer. That's when it's going to be in the 90s. Okay. Oops, turn this sound off. All right, that was an aside. Let's see if this works. And I do suggest everyone take walks, by the way. I know this is silly advice, and you don't need to listen to me, but I find walks are helpful for my mental health and physical health. I try to do 2 or 3 walks a day. Okay, well, I need to turn off this other shoot because that's just silly now. Okay, so we're gonna turn that off so we can just see our arrow and see if it works. The arrow is gonna have to adjust its own angle probably as it flies through the air. Look at that. It's definitely going. It appears to be going through the center of mass. It's definitely not angled right. All right, so let's fix that. Let's look at our arrow. There's probably a script on it already. There's no script on it already. Well, let's add one. Arrow flight. Create an ad. Oof, I should have done it somewhere else. I always have to remember to put the scripts into the right folder here, and at some point I need to clean up this project too, because there's a lot of stuff that's not used, not needed. Scripts will be... I'll just move it to scripts, but where is it? Arrow flight. All of these. Look at that. I forgot on all of these. Just move it there. Okay. All right. Oops. Where'd it go? Scripts. There. Okay, so we're going to need to know what we're... Well, I guess we don't necessarily need to know what we're looking at. We might not need that anymore. Okay. So we're going to say, when we create this, shoot. Okay, let me clean this up a little bit. All right. Okay. Arrow flight equals new arrow dot get component arrow flight. Okay, and we're going to say arrow flight dot look at, and pass in hover enemy. So it starts kind of looking at the right place. And for this one, we're just going to say transform dot you want to transform dot look at, and we're going to actually make this a transform. Look at, we'll call it that. Look at, and we'll actually make this position so that it's more clear. And here we will pass in this transform. Okay. I think that would work. And then void update. We're definitely gonna have to add some more stuff, but for now we're just gonna save vector 3 last position. Make that the underscore, and so handle look at and create that, and then we're gonna add another variable here. We're going to say if not active, then return, because we want to know if it's active. It starts out as active, and for now it's just going to stay active, but when it hits something like a wall or another object, it's no longer going to become active. At that point, I want it to just react to regular old physics. And so it's no longer going to be looking at the thing, it's, you know, the trajectory. It's just going to react and fall on the ground or whatever. So that should work. But for now, it's just going to remain active. So if it's not, then we're going to say what are we doing? We want to look at basically where its last position to its current position. We want it to look at that direction. Because we don't know where it's going to be next frame, but we know where it was. So at the end of this, we're going to say last position equals transform.position. And so if we get the distance between, I don't know, we don't really need that. We just need to get the direction between the two, and then add. What do you mean inverse of that? No, you're typing on your phone now, so it's harder while walking. If I get the direction, then I can just add, you know, 0.1 in that direction, and I did that with the direction here. So we take our last position, subtract our current position, direction will be that. So look at position will be its current position, right? No. Yeah, transform position plus the direction times 1.1. And then we will say look at target. See if that works. That should basically say, hey, if there's like 1 meter, it's not going to be 1 meter, but if there's 1 meter between them, it will look at 1.1 meters ahead of the last position in the direction of the current position. So essentially 10% of the last frame's distance traveled, and that would be roughly in front of it. And since there's enough frames, it should look like an arc. That was the suggestions I was reading last night on the forums. That did not work. I think we need to move time scale down too. Wrong button. Oops, wrong button again. Okay. Oh, I should have zoomed in. I apologize. I didn't zoom in there. Arrow system. Shoot. So temporarily, I'm going to say time.timescale equals 0.3. Just to see. Did my Unity quit? What happened to Unity? Where'd it go? That's weird. Where's Unity all of a sudden? That's weird. It totally went to the other monitor. This is very... Alright, it's back. I must have... Sometimes I feel like if it's loading and you accidentally click something, it will have... Where's the game view now? Layouts. Streaming. There we go. Okay. We're back to normal-ish. Alright, so now time scale should slow down, so we should get a better sense of what the heck the arrow's actually doing. It'll slow down when we shoot. Oh, interesting. So it does look like it's going through. It's just when it launches it, that first frame is... And I think, are we also shooting a ball out? Yeah, we need to slow it down even more. So slow down even more. And then this is interesting. It appears to not actually be looking at. Okay, how about instead of that, we'll do we'll do arrow flight look at game dot player camera dot transform dot forward dot position plus game dot player dot camera dot transform dot forward times 0. Yeah. Okay. It's position plus forward. Let's try that. Yeah, I blame the Mac too. Specifically, I blame Steve Jobs. You know, this whole arrow system would have been a lot easier if I just said arrow shoot straight forward and that's that. Deal with it. But that's okay. Okay, this is weird. So, I'm seeing two things. Oh, that's a ball that's going way off in the distance. And then the arrow. Whoops. Oh gosh, I just selected so many things. Okay. So there's the arrow. And it goes through. Oh, look at that. It's actually looking backwards. And apparently there is a ball still going off into the distance. And then that arrow thing needs to... Okay, so I think I'm going to do a couple things. What am I going to do? First, let's do the fact that it's looking backwards. Is it? It could be backwards. The arrow. I haven't actually looked at this in a bit, so let's look at the arrow. All right, it appears to be in the correct direction. All right, so the arrow appears to be fine. And this is the inverse thing that the bull meant. So is it the heading then that I need to inverse? Maybe. Maybe. Yes. All right. Thank you, the bull. So that part appears to be working. I need a particle trail on this because clearly that's not easily seen, I think. And then I think I need to start it behind the camera rather than at the camera's position. Well, actually, so somewhere I think I have arrow spawn position. There we go. I have a spawn position. Okay. So I'm going to include this in arrow system. So now when we shoot, we're going to do it here. that work? Okay. We'll start at the same rotation as that. Maybe that will work. And then in actions, arrow spawn position, press play. Ooh. We lost our goblin here. Oh. Weird. Since it's lower. Oh. Do you know why? I think I know why. Okay, first of all, I can make the speed a little bit faster, I think. But I still want it slow for now. I think because camera position. Because we're still using this. So we still need the camera position for that, but we don't need it for huh. Interesting. I wonder if the angle was wrong because I was shooting it from a different height. Would that have that's such a small amount though. Like if I do the player's transform position versus the arrow shoot position, which is basically like a meter up, that the distance to the enemy is basically the same. Yeah, so that wouldn't be it. But I might need to modify my modifier here. Let's see. Definitely going a little lower. Oh, I can still see it to the side sometimes. So sometimes it ends up at the side, sometimes it doesn't. That's weird. I'll have to figure that out. But it's closer. And now, so this, sort of modifier 1.55. Let's see that. Still kind of low. All right. Seems higher. It's too low when we get close. As we get further back, it gets higher. To where it's too high. Damn it. I mean, it's close enough, probably. But not really, because right here, it's just, it needs to be centered. And it's clearly aiming low. All right. All right, so that's, I mean, so the difference between the math, right? The math difference between my angle calculation and the physics force add force calculation is greater now that the start position is different. Let me just try one other thing here, because I do wonder if height of the player matters. So if I go down low, that's really low. As we get closer, it's still low. Okay. My time scale's now really slow. Okay, now if we're on the other side, it seems higher. And it's not really gained much higher, but we are gained higher. The thing is, Corey, that's a good question, because the thing is, the angle calculation doesn't use any of that at all. Oops, arrow system. Get angle. So this just takes in the distance. That just takes in a distance. I think this is also one bit of code that I just don't understand, of course. That's always a problem. So, thinking out loud, since it's a live stream, if I think in my head, then it's more boring. I guess the problem comes down to I still need this get angle to basically essentially be a reverse of the add force, to do a prediction of the add force. It's from the character's position to the bad guy's position. Distance equals distance to enemy, and that's where we set hover enemy. Right here. Distance to enemy is the hit transforms position to the player's transform position. So I could change this to arrow. Oops. What do we have? Game.arrow. We don't have that. Player camera. I could change it to player camera. So I could just do this. And see if that changes anything. I don't know. It should be the arrow spawn point, but it's such a close position. I guess I wouldn't have expected to have such a huge change, you know, because it's all of a meter or two higher, and as far as distance goes, rising by that little bit shouldn't have a huge impact, I would think, but yeah, it's still just too low. And the reality is, if we didn't do the mod at all, if we were just doing one, then it would be much lower. Yeah, like it's hitting the ground. And I mean, we can kind of, let's say the position check plus vector 3.up. So make that 1 meter higher too. So instead of down here, it's here. Maybe that matters. Maybe it does. Let's find out. Oops. Oh. Corey, you might be the genius of the day. All right. 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 Calm down, everybody. So for this distance to player, we do want this. However, in arrow system, that's a different calculation. I didn't want to do distance twice, but arrow target position. Let's see if you are the genius of the day. Okay, so what we're really looking for here is for angle. In get angle, we're going to look for distance to arrow target. And this is going to be straight up vector 3.distance from the to that. It's going to be from the spawn position, arrow spawn position dot position. This shouldn't be called position. This is arrow spawn transform. Okay. So if that takes into account now the exact distance from the start to the end, and I fix whatever bug this is. We need to return that. Oh, my mod's still up, so we move our mod to 1, so there is no mod. Did it go through? No. They're hitting the ground. They're hitting the feet. Did I do this right? Okay, well, that part's right. Arrow spawn transform. That should be right too. Why is this up there anyways? Can we make it down somewhere more appropriate? Okay. So that should be right too. They're landing at the feet. And they're going up. So that's too bad. So essentially, this is why I think I was using the mod, because it seemed like it was too low here, and it got progressively lower as I went back. So using the mod did the trick. So now it's going a little lower. It's too low. But it was consistent, at least. If we look at this, we got the arrow target here. So that's our arrow target. So it's almost getting there, but if I go closer, it gets lower. I know, physics shouldn't need to be jerry-rigged. Who do I think I am, God? So that brings us back to where we were before. Before Corey decided to become a genius. And that is where... I mean, kind of, you know... So, Corey, when I did that test just by adding vector 3 up to 1 meter, I only changed this. Let's try that again. Oh, and I need to change the... Oh, the angle mod is right. So, let's see. Where's it going? Where are the arrows going? Oh, they're still laying at the feet. Yeah. All right. Yeah. I don't know. Huh. Let's go crazy. angle was like 76 something, 75, whatever. So let's see if we multiply that by 5, just to go cray-cray and give an extreme example, just to see what the change does, if anything. Okay, angle's now 73. And it's still going at the feet. Arrow spawn transform dot position to arrow target position, and we will do color dot cyan, and we'll do it for 2 seconds. So we're going to draw a line just to visualize that. Make sure we're putting the what we think we're putting in. Should give us a nice blue line between the arrow position and the target. And it sure enough does. Okay, so we've got the positions correct. And just to be clear that we're shooting it up at an angle. If it were a straight line, it would just go follow that blue line. The arrows would. But they are being shot up at an angle. It's just the angle isn't big enough. And that's where angle mod comes into play. To visualize that. The angle's bigger now. So what I'm thinking is that this just is not right. This isn't getting the angle I need. I don't know why, though. Is it because y is 0? What happens if I make y 1? Is it still hitting the ground? Is it hitting the ground even earlier? No, it's hitting the ground back there. Was that... It's back here. Alright, let's see if it hits the ground in the same spot. Could make this a variable. Same spot. Okay, well, what if we make this a huge number? Because this comes into play right here. If it's 0, then this is 0. Wherever yv2 is used. And it gets to the exact same spot. Weird, right? So I have no idea what y means in this context. But clearly this is always going to be 0. So this is just gx squared times g v4 minus that. Velocity to the 4th minus gravity times. I mean, you might as well make that g2 and x2. G squared x squared, right? Does it fall at the same spot every time, regardless of my distance? Let's find out. Nope. As I get closer, it gets further, but at a smaller degree than my closeness. If that makes sense. So we see the angle. I don't know. And just to be super clear, we're adding 90 to the actual angle that's being printed out there. So really close, it would be a shallow angle of 4 degrees. And further away, it would be a bigger angle, and bigger angle, and bigger angle, and bigger angle, so that the angle is higher the further away you go. Well, I mean, there we are, right? I think this just is not giving me the correct angle then. I mean, let me just check my rigid body. So we're taking the angle, multiplying by the angle mod, which is 1 right now, so that's fine. Gain the angle, adding 90 to it. Then we normalize it by dividing it by 90. So if it were straight up and down, it would be 1. If it were... So I suppose this could be where I go wrong too. The normalized angle when the add force, without doing this, it was just flat. There were some examples that always seem to multiply the speed or velocity by itself. I don't know why. That sounds like a physics thing, but I've seen some examples of that, so... At some point I need to make a demo and get this into all of your hands, and you can tell me how you feel about the controls, because I never know like mouse look is really cool. Did I not press play? I didn't press play. Mouse look is really cool, and I think that's like, you know, better than the Might and Magic 6 route where you use the arrow keys to turn and look and stuff, or whatnot. But it does make it hard to target because you can't point at things, so you have to hit control to freeze the rotation. Where are the arrows going now? So now the arrows are going much faster. And going who knows where. Oops. I don't see them. I need to add a trail to this. Oh, there they are. Way up there. Yeah, so that doesn't appear correct. Or was it speed plus speed? It's a physics thing. It's probably a good answer to many of life's quandaries. All right. Attempt 85. All right, well, I mean, this is not much different than doing another mod, but it's clearly not right either. So let's do speed. It could be that I'm doing something wrong here. Where do I print this out? Mm-hmm. Well, 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 well. Now I'm looking for a particle thing. Not from Acid Store, from my own stuff. Where are my particles? They're still in the old system. They are. They're in the old. That's how long it's been. Light tail. That's what we P component light tail. Where's my arrow again? Arrow. It's in, oh, projectiles, duh. Huh. Open this, add P component, light tail. Can we not, why can't we? Oh, like that. And make it 0. Now when we move this, does it do something? It does. All right. Save that. The spheres were doing the same thing. All right. I think I can stop the time dot scale thing. All right, I might need to take a break at this point. This is I don't know. I think I just need to get a better code for that physics bit, or figure out if I'm doing something wrong. Go back to school and get a physics degree. That particle trail looks weird in the game view. Well, I don't know. Or closer. Closer than I was at the start. Closer than I was at the start. All right. Well, yeah. So I don't know. I think I'm gonna go for a walk myself, and maybe something will come up. I since I made this code, I figure this could be where the issue is. It seemed to work. I'm with just negative direction, then it fires in the right direction, but it's a straight. And then since we're including gravity, that matters. It falls down flat. So we added this normalized angle to the direction. And we multiply by the force, which is the speed here. But that's the other thing, though. Is force the same as velocity? Let's ask the internet. Is force the same as velocity? That's not exactly helpful. Oh, I hate Quora. I'm not going to look at that. Okay, that seems like self-help. Yeah. So because this is looking for force, right? This is basically saying, give me a force in that direction, and this is the magnitude of that force, right? So this is the direction, or the angle, the direction, yeah, and then this is the magnitude of the force. But speed is meant to be velocity, and in my get angle thing that I stole, it looks like speed is v, which is velocity. Is there a relationship between force and velocity? It does. So I mean, I guess what I'm really looking at is how can I use speed here? That is helpful in some regard. I mean, the force of the initial arrow shoot causes it to have a certain velocity, but that velocity will change over time, right? Technically, I guess it would slow down or speed up, but probably slow down in this case. And that could be what's happening, is that it's this algorithm assumes a constant velocity of v, whereas once the arrow's shot, the velocity slows down. I'm specifically trying to figure out, assuming that v means velocity, how can I provide the right number, a single number, or how can I get the angle? This needs to take into account the okay. So this, if that's the assumption that things are going wrong because force is not velocity, therefore rigid body add force, adding the same value here as velocity is not going to give me the same result. So what this is basically telling me is, if I shoot the arrow at this angle and every distance, keeping it the same velocity through that entire journey, that I also bring it down by gravity during its journey, it should land on that spot. So instead of doing rigid body add force, I would need to simply use the transform, translate, or whatever, and move it forward every frame, but also bring it down by gravity every frame. So I'd be saying I'm going to move it forward by speed every frame and bring down its position by gravity every frame. And then technically, when it gets to the distance, it should be at that target. And I don't give a shit about air resistance for this game. Even though there's going to be weather, and I know, raindrops will affect the trajectory of a projectile. We're ignoring all that. Wind as well. We're ignoring wind because, you know what? It's not that kind of game. So that's why I should try. Okay, so let me just quickly see if I can quickly do something. Instantiate. Okay, so arrow flight dot speed. We'll say velocity. Set velocity. Speed. And then okay. And then so we have the velocity set to speed. We know gravity, that's physics gravity, so we got that. We need it to look at this. So we're basically saying look at its position plus that. um, and then move transform dot whoops. I always mess up on moving to it. It's a so simple thing. It's just transform translate, I think, right? Game object dot transform dot translate. I don't know if there's a simpler way to get the angle. You know, I would think there might be, but I don't know. Interesting. I know the order of multiplication matters, but that's okay. Good to know. So we move forward, and then we also move down by gravity. Is that right? Wow, it just reordered this, and I guess it's the same result. No, that's not right. I don't think this is going to give the right result. Let's see what happens. At least we have the trail on it now. Wow. That did not go as planned. All right, that's fine. Let's remove gravity for now. Let's see if we can just get it to fly in a straight line. No, I don't know what it's doing, but it's not doing. What did I do before? This is what I used to do. Oh, because probably not transform forward. Ah, I need to add this up here. Okay. I'll just do that. All right, so that's similar but different. I think that would cause a drop. That's where we have to add gravity. But first I want to just get it to go straight at the right angle. If I can get it to go straight, but starting at the right angle, then add the gravity, that might work. Okay, I don't know why the trail is. Oops, wait. That's weird, right? I don't know. Let me try one more thing. Just want to see something. Oh, hey, look at that. It didn't go crazy. But I didn't change anything, right? What's... Oh, it's doing a look at thing later, though. Right. Right. I don't know why that changed, but it's doing this. Okay. So let's stop doing this handle look at. I might have to embed the arrow model as a child of the prefab. So the prefab just goes on its curve and the arrow just changes its direction. It's a good process, Neil. Keep trying random things until it looks right. There it is. Interesting though that it is it following the same? Is it having the same result? Because gravity's affecting it. Okay. So gravity's affecting it. Which is why it's essentially having the same result. It's landing in the same spot as when we did the rigid body method. So if we revert, essentially, which I just have to change those comments, and then on arrow system, remove this, and that's fine. That's fine too. I think I should have done more of the player movement to confirm that it was the exact same. Ooh, I can always revert back. Okay. Oh, I must have hit this twice. My apologies. I want these to auto-target a position. They won't necessarily hit the enemy, but that's the next step. Once I can get to... Yeah, I need to know... well, that's a different... You're bringing in a whole different thing. That's now predicting where it's going to go. I don't know why that target looks so weird in the game view, but it looks fine in the other view. Okay, so with the rigid body add force method, this is what we get at the feet from lower, at the crotch when you're closer. Let's revert back again. On this and this. I don't know what those clicks are. If you hear those audio clicks, it might be the input. I might just be hearing them from my speakers on the laptop. Who knows? For the movement, it's literally just going to take their current movement and add that or modify the target by some value to predict their movement. If the enemy then changes direction, then they'll miss and all that stuff. But okay, so again at the feet, we go closer. Okay, so it is different. It is a different outcome in the end. It's just a very similar outcome. Like from real... Oops. We need to get closer. So, It's not a direct, like I move 10 meters forward, it doesn't land 10 meters further away. It's a closer result, but it's still not right. The angle is still off, in other words. So gravity's taking hold because there's a rigid body. And we can test this, I suppose, by going to our prefabs, projectiles, and where's the rigid body? Is there no rigid body? Oh. There's no rigid body. So why is it going down? And curve. Oops, wrong view. Yeah, I don't know. It also seems to not be the same every single time. The trail's moving around, which isn't ideal either, because I would think it would be the same every time. So I think I will continue trying. Whoops. I will continue trying the move version, or the handle look at version, and this is the physics version. I will continue trying this because this seems like the better way of doing it. Interesting though, the arrow doesn't have a rigid body. And now it goes straight down. I'm also getting a null reference. What's my null reference? Why would... Oh, rigid body. Oh, I was adding the component. Interesting. Okay. Let's do instead. Okay. All right, let's play with this rigid body and see if any of these things affect it. All right. lands at the feet. If we change our angular drag to 0, lands at the feet. If we don't use gravity, go straight line. It's always cool to see. Okay, but we do want gravity. If we have less mass, whoops. So maybe the trick is just to have less mass. I don't know what the mass of an arrow is. See, but this is still a problem, is that it's too low here. And as we get further away, it gets too high. So it's kind of like that, the modifier I was doing earlier. That's cool. What's this? Speed 22. Interesting. Interesting. So if my speed is essentially, well, it's speeding up now, that's going down, but if it's essentially 22, let's add a force value. So we'll say 22 and 15. And where we said speed, sometimes we'll now use force. We'll use speed for set velocity. But for this, we're going to use force. But for the angle calculations, we're going to use velocity or speed. And that, okay. Interesting. Still low there, but better here.
Come on, we need to get closer.
Just make sure I'm not doing any of my funny business stuff with the angle mods not being affected. So, oh. Okay. So now it's too low. So if I make the speed higher, then it goes, the angle changes. Oh. That's clearly not right. I guess because I'm trying to mimic what's the average velocity going to be during the trip. And if I'm closer, the average velocity is going to be a little bit lower. So it goes a little bit higher. But if I'm further away, then that value needs to be higher. To get the same spot. Well, all right. So I do think there is a simpler way. There's got to be a simpler way. But I think what it's coming down to is force and velocity not being the same thing. It just happened to be that 15 and 15 were giving a decent result. The calculation of the angle requires a velocity. So it's not actually calculating what angle would be if I added this force to an object. It's calculating if the object had a constant velocity of x, what would the angle need to be given gravity. Whereas the physics engine is doing, let me add this amount of force. The velocity is going to change over time. At the beginning, it's going to slow down as it goes up to its crest and fights gravity. And then the velocity is going to increase. The speed is going to increase as it goes down with gravity. So there's two different things there. And that means that the distance between the target and the source is important because the velocity, the speed changes. The average speed of that trip changes depending on the distance. So what I really need is essentially the get angle to almost be a sample of the physics engine, but a backward sample where I give it the force I'm going to apply, I give it the source and destination positions, and then it tells me what angle I need to perform that or whatnot. It gives me the direction basically. I'm shooting from here to here at this force. What's the direction I need to shoot it at in order to hit that target? So I'm going to go for a walk, though, because it's now been 4 hours, and that's too long to be sitting in one spot. Need some motion, need some water, probably some more coffee, and go from there. So that's that. I think we're on our way, much closer than I was 4 hours ago. I know 4 hours is a long time, but it's going to be worth it probably, hopefully, maybe, we'll see. So I want to thank you all for coming out to watch. I will be streaming again at some point in the future, maybe tomorrow. I think all my few friends are busy, so maybe tomorrow I'll be streaming again. I will try to pre-schedule the streams like I did today, so you all can see in advance when I'm going to be doing it. There will probably be impromptu ones as well, though. Maybe I'll do it tonight again. You never know. God, yeah. Closer. We're closer. Just a little bit closer. And once this arrow system is working, my plan is to make it its own little type of thing, and basically a package that you could download from the Asset Store for free that just does this one thing. Says give me a start, give me a end, the source position, the target position, give me the force. I will tell you exactly what angle you need to release that at to hit that target. that's what I want to provide for folks. And I think that will be helpful. Once I do that, then I can use that for this. I can use that for magic spells, for the enemies shooting at the player, and all that stuff. And then in the flight trajectory, if it hits the ceiling or something, then the arrow doesn't hit the target. Yeah. All right. Thanks, everyone. Have a great day.